All right, one last question about this circle. We've evaluated its first derivative and second derivative of y with respect to x to find the slope and the concavity. Now we're asking about the slope at the tangent, the slope of the tangent line at the pole, and we're going to try to figure out a nice generalization here. So let's remind ourselves what this graph looks like again. We're talking about the graph of the red circle, r equals -4 cosine theta. Clearly the blue one doesn't have any tangent line at the pole because 2 never equals 0. But -4 cosine of theta does equal 0 sometimes, right? In fact, it equals 0 when theta equals pi over 2, and when theta equals 3 pi over 2. Now, one thing we're noticing here is this tangent line of the red circle at the pole is, in fact, the line theta equals pi over 2. And, of course, the same line, theta equals 3 pi over 2. So that's actually a phenomenon that's always going to be true for polar graphs. If you want to know the equation of the tangent line at the pole, then you just set the r value equal to 0 and solve for theta. Solve for theta equals whatever particular value it is. We actually saw that back on the 10.4a notes when we were graphing these petals. Remember that r equals 0 when theta equals pi over 6. Pi over 6 was one of those tangent lines we drew. R equals 0 when theta equals pi over 2. Theta equals pi over 2 is another tangent line. And then r equals 0 when theta equals 5 pi over 6. And 5 pi over 6 was the third tangent line that we drew, and that helped guide us to make sure that the petals that we drew did not cross over those tangent lines. So the only time this might not be true is if dr d theta equals 0 at the pole as well, which doesn't tend to happen, but will sometimes happen. So for this particular question, if r equals -4 cosine of theta, then we set that equal to 0. We find that the cosine of theta equals 0 when theta equals pi over 2. And also when theta equals 3 pi over 2. Now both of these equations represent the same line, so we don't really need both of them. But that is the equation of the line tangent to the curve at the pole. I guess the last piece we should double check is dr d theta equal to 0? And of course we know that it's not. Dr d theta is equal to 4 sine of theta. And if I evaluate 4 sine of theta when theta equals pi over 2 or 3 pi over 2, I get 4 or -4. I don't get 0. It is not equal to 0 at theta equals pi over 2. So that's an extra little piece that we have to check. Anyway, short and sweet.